Christmas Eve 2024, while the world was wrapping gifts, NASA did something scientists once called impossible. They flew a spacecraft directly into the sun. Not near it, not close to it, into it. And it was moving at 430,000 miles per hour, New York to Los Angeles in 20 seconds. Then, silence. No signal, no data, nothing. The team could only wait. This is how humanity touched a star, and what we found when we did. Most people think the sun is dangerous because it's hot. Sure, the surface burns at 10,000 degrees Fahrenheit, hot enough to melt anything you can imagine. But the surface, that's not even the scary part. The corona is. It's the sun's outer atmosphere, an invisible shell of plasma stretching millions of miles into space. And here's where it gets insane. The surface is 10,000 degrees Fahrenheit. The corona, up to 3 million degrees. 300 times hotter farther away from the sun. That breaks the basic laws of thermodynamics. Move away from a fire, it gets cooler. The sun does the opposite. Scientists called it the coronal heating problem, and for 80 years, nobody could explain it. And it's not just a science mystery. The corona is where the solar wind is born, a constant blast of charged particles flying toward Earth at hundreds of miles per second. Hit us hard enough, satellites down, GPS gone, power grids fried. We're talking civilization-level damage. The spacecraft is named after a person. NASA almost never does that. Here's why they did. In 1958, a young astrophysicist named Eugene Parker published a paper claiming the sun constantly shoots a stream of charged particles across the solar system. He called it the solar wind. Reviewers rejected it, called it impossible. He appealed. It got published. 2 years later, Spacecraft confirmed he was completely right. When NASA prepared to send a probe into the sun's atmosphere, they named it after him. Parker was 91 at the launch. He stood on that pad in Florida and watched his name rocket into the sky. He died in 2022 at 94, having watched his spacecraft begin rewriting everything we know about the sun. That's how significant this mission was. How do you build something that survives inside a star? The sun-facing shield hits 2,500 degrees Fahrenheit, hotter than lava, hot enough to melt steel. But the instruments right behind it, a comfortable 85 degrees, room temperature, separated just 4.5 inches of material. That material is carbon foam, 97% air, sandwiched between carbon-carbon composite panels, coated in reflective white paint, one of the most effective heat shields ever built. And here's the twist most people miss. The corona is 1,000,000 degrees, but the probe doesn't vaporize, because temperature and heat are not the same thing. The corona is nearly a perfect vacuum. Particles are moving fast, but there are almost none of them, so the actual heat delivered to the shield, manageable. It's not swimming through fire. It's flying through an incredibly hot emptiness. Parker launched in 2018 but couldn't fly straight to the sun. Too much orbital velocity. Instead, it looped around Venus 7 times over 6 years, using Venus's gravity to slowly tighten its orbit, like reeling in a fishing line. Each pass got closer. Each pass set a new record. Along the way, it was already finding things. Strange magnetic zigzags called switchbacks. Solar wind far more turbulent than predicted. Coronal mass ejections measured from the inside for the first time ever. Then, November 2024, final Venus flyby. After that, nothing left to do but fall toward the sun. December 24th, 2024, the team at Johns Hopkins wasn't celebrating. They were watching their spacecraft disappear. As Parker approached the sun, it entered a communications blackout, electromagnetic radiation so intense it drowned out every signal. No telemetry, no beacon, nothing. Their spacecraft, a machine over a decade in the making, was flying autopilot through the atmosphere of a star, completely unreachable, at 430,000 miles per hour. For context, Mercury, the closest planet to the sun, never gets within 28 million miles of the surface. Parker was 7 times closer. Then, December 26th, a signal. I'm here. I'm operational. Everything is working normally. The room erupted. When the data came back in January 2025, it was unlike anything before. For the first time, scientists watched the solar wind being born, plasma pulling away from the corona, accelerating outward, organizing into the streams that eventually hit Earth, like finally watching a river at its source after only ever seeing it downstream. They filmed solar wind U-turns, ejected plasma looping back toward the sun, reshaping the corona, influencing the next explosion, never captured like this before. And the coronal heating mystery? The data is pointing to those switchbacks, magnetic reversals triggering waves of energy transfer from the surface into the corona. 80 years of mystery, finally getting an answer. Right now, when a major solar storm is incoming, we get 15 minutes to a few hours of warning, barely enough to protect satellites, not nearly enough for power grids. A storm like the 1859 Carrington event today could knock out power across entire continents. Recovery could take years, trillions of dollars, millions of lives disrupted. Parker's data, seeing storms form at the source, could push that warning window from 15 minutes to days. That's not just science, that's protection for the civilization we've built. On Christmas Eve 2024, a machine built by human hands flew into a star. It survived. It came back with answers. For thousands of years, the sun was untouchable, a god, a mystery beyond reach. NASA reached anyway, and what Parker found inside is going to change how we understand our star and how well we can protect everything beneath it. If this hit different, drop a like, it seriously helps, and subscribe, because next we're covering what James Webb found at the edge of the universe, something that, according to every model we had, simply should not exist.